In the last two videos, we took a finite state machine and converted it to a circuit. And in doing so, we took the easy way out. We used a D flip-flop because a D flip-flop has one input and one output. I want you to take this to the next level. So I want you to implement this now using a JK flip-flop. So in order to do that, remember, you're going to need one flip-flop for P1 for 1 bit. And you'll need a second flip-flop for P0. So I've added these 4 columns to the truth table, which is your first step in the process. So I need a value for J and for K for N1 flip-flop. I need a value for J and K for the N0. So the question you need to answer is, P1's value is a 0. My next state, N1 value, is a 0. What are the inputs to my flip-flop in order to get from a 0 to a 0? That's the question you need to answer, and those are the values that go here. Okay, to answer the question, go over to our excitation tables, and these are in the Chapter 3 PowerPoint on slide 11. And here's the excitation table for a JK flip-flop. So QT is present state, QT plus 1 is next state. So from a 0 to a 0, the value for J must be a 0, and the value for K can be either a 0 or 1. So use this table to populate your truth table. So if we go back to our truth table, right here, my present value is 0. My next state value is 0. J, we'll flip back over. J must be a 0, and K can be anything. So fill that in here. Right? And continue to do that for every one. Now there's no change here. Again, we're at 0 going to 0. So this stays the same. At 0 going to 0. Stays the same. And here we see our first change. So we're at 0, we're going to a 1. At 0, going to a 1, right? So this is present, this is next. 1, J must be a 1, X can be, K can be either a 0 or a 1. So again, populate this in your truth table. All right, so continue to do that for these 2 columns, and then again for these 2 columns. So now you've defined the values that you need for J, K, and on the first flip-flop, J, K on the second flip-flop. The information you need then is equations for each of those. So you don't need equations for these. This was 1 input, 1 output with a D flip-flop. I'm going to actually just cross those out. You need equations for your S still, which hasn't changed. But you need the equations for each one of these because you are replacing the D flip-flops, 1 input, 1 output, with the 2 JK flip-flops. So you have to define each one of those, define a K-map for each one, right? Simplify each of those 4 equations, and then plot them in the circuit. So go ahead and take those next steps, build your circuit in Cedar Logic, and let's see how you do.